Hello, everyone. Thank you for being here in the Aspen room for the final presentation before lunchtime. Looks like it's going to be a good one. I'm Allison Zach from the Human Beaver Coexistence Fund, and I am excited to introduce Dr. Rory Cowie. He has also the honor of having the longest title of presentations that I've introduced today, so I'm going to let him explain it. Thanks.
All right, thanks everyone for coming. Again, my name is Rory Cowie, and excited to be back here. I did my PhD at CU Boulder, and this is the first time back on campus since then. Obviously, I want to first start out to acknowledge the lands that we're on today, the Ute peoples, and specifically in my talk, we'll be focusing on a watershed that's the homelands of the Southern Ute and the Intermountain Ute. So my talk today is about the integration of beaver habitat preservation and restoration into the watershed scale remediation of abandoned mine lands. And I'm hoping to kind of poke some curiosity in folks, bring up questions, and initiate collaborators to work on some of these questions I'm going to pose today. So by no means is this solution, this is just big picture thinking. So a little backstory for me, this is actually, will be my 19th year working on beaver flow structures. When I finished college, I wanted to go to be a ski bum for a little bit. I ended up in Telluride, Colorado, and they hired me to be the town beaver monitor. I didn't know that was a job. And Skip Lyles, who some of you may know, came out from Vermont and showed me how to build flow devices and beaver deceivers, and never really thought that it would still continue 2 decades on to be a part of my eventual career. Just a quick overview, Telluride, Colorado, these are the wetland areas very, very closely adjacent to a lot of development in the area. Stars are where we put flow devices. We were able to get hydrology connected between the river and these isolated wetlands in the midst of very dense population development. I like to show this. This is from the newspaper in 2005 of the install of this flow device. And I went back this summer, so 19 years later, device is still working, no maintenance, and it's still flowing. So just to give you a little scale of it can work. And then to keep it funny, this is the condos that are adjacent to this. The condo on the left, the folks that owned it in the 90s put rat poison in here and killed all the beavers. And now they've evolved to coexistence, and I think no further mention necessary, but it's the existence of beaver ponds is not affecting real estate values in a negative way. So what am I talking about today? Talking about Colorado, and just an overview for folks that aren't here. We have about 300 mining districts in the state. We have at least 20,000 abandoned mines, and I'm going to focus on southwest Colorado in the San Juans and what's now called the Bonita Peak Mining District in the Animas River Watershed. So again, the Animas River Watershed is the headwaters to the San Juan, and so all the water ends up in Lake Powell and the Colorado River system. So we're going to be focusing on the headwaters in Silverton, 5 major rivers within about 30 miles here, and I think as Governor Polis said, there's something like 40 million people downstream in both directions here, because we're right on the divide. So just an overview of the watershed. Silverton sits in a volcanic caldera. These mountains are 20 to 25 million years old, the San Juan volcanic fields. So they're fairly young for mountains in the Rockies, and steep high gradient slopes. And it's really important to know that this is a glaciated valleys, and I'll talk more about the impact of glacier on geomorphology and landscape formation in relation to where beavers are existing. Recently, I've gone out and mapped where there's current or historical beaver activity, historical being, fresh enough to see, and it's pretty well dispersed across the watershed. And what's interesting here is we also have a mining district and a Superfund site here. So I don't know if anybody remembers the Animas River turning orange about 10 years ago, got a lot of national attention. There was a mine release, turned into a Superfund site. And I currently am the site manager for 48 mine sites that are being cleaned up under the Superfund program. And these historic sites have contaminated soil and groundwater, surface water with heavy metals. low pH water, metals chemistry. It's really complex. I won't have time to talk about all of it, but those are the contaminants of concern. What's interesting is that the terrestrial baseline risk assessment says that, by the EPA, says that the small range herbivores, including beavers, are minimally affected by this pollution because they're not an aquatic species. They don't fall under the fish and the benthic kind of levels of contaminant. They live in the water, but they don't eat the water or eat things in the water, so it's complicated. So there's metal concentrations in these waters, but there's also natural background due to the mineralogy of the volcanic formations. We have a lot of natural mineralization. These watersheds are not pristine in a sense to begin with. And aquatic life varies dramatically by reach here. We have native cutthroat populations in tributaries, and then we have tributaries that have not a single bug in them. So, and they could be within a mile of each other. So it's very spatially heterogeneous. So if we look at the contaminant source areas, all of these are the 48 sites that I'm trying to do an investigation on to figure out how to clean up at the Superfund level. And if you overlay them with beaver habitat and currently existing, so we don't need to relocate. The beavers are here, and trying to understand this riverscape corridors and connectivity that we've heard a lot about this week. There's an interplay here between this remediated landscapes and habitat that's healthy and functioning. So goals is to look at the relationship between beavers and mine-impacted water. I really want to work with folks to understand some solutions in these areas by legacy mining. What's interesting is, to put it in perspective, the Superfund site's probably going to spend $200 to $300 million in the site to do Superfund cleanup. And when we're talking low-tech restoration, a little bit of that money could go a long ways. So where have I been able to get funding to do this? All of these agencies listed here are currently providing funding or labor or both. Superfund, the Abandoned Mine Lands Program with BLM, Forest Service, CDPHE, Division of Mining Reclamation, the U.S. Geological Survey is doing research with us. I'm working with the Colorado Department of Transportation to look at infrastructure protection as we develop these expanded landscapes. And then Bureau of Rec, I've put in a new grant with the Water Smart Drought Response Program for future funding. And right now, a lot of the funding I'm using for this talk is coming from the WIN Act, which is actually expiring. But we have WIN Act funding, which has enabled me to hire several undergrad interns to come work with me the last couple summers and collect the data. And then, of course, local governments. And I want to shout out a few folks, Ecometrics, who's here. I have a few slides of their work, Trout Unlimited, and some other folks, Mountain Studies Institute, and then again, universities. I'm a research affiliate here at CU and at the Colorado School of Mines, so I work with graduate level students doing research in the area because we're a long ways from the universities. So what I'm going to do is kind of talk about 4 or 5 different examples so you can kind of get a visual idea of what we're talking about and some of the interactions. This first one is the Mighty Monarch Mine, and this is a nice, healthy beaver pond. It's been actively working for at least 40 or 50 years. That's the locals have, seen it. And this pond is actually supported by mine drainage coming from a mine up above, and that's the perennial water source adjacent to the riverways. And so one of the things I'm doing, and I don't want to go a lot into data, but we are collecting data because the quantitative question will come up. We're looking at metals concentrations in these wetland habitats because it all relates to is there chronic, acute toxicity issues, and all of these these ponds I've studied and complexes have very different geochemistry. And so just highlighting, we're at the very tip of the iceberg. We're starting to collect metals data and understand where are they living. We haven't put them in the environment. They're there, and where there are limits to where we can think about expansion as we clean up certain landscapes. So another one, this is one of my favorite ones. This is the Chattanooga Fen on Highway 550. If you look at this landscape, You can tell there's a lot of historic beaver activity. This is also a fen. We've cored this fen. The peat is 5,000 to 7,000 years old. It's been there for a while since the deglaciation and the end of the Pleistocene. But this landscape obviously was a town of 500 people in the mining days. So they bulldozed the river into a straight channel. So there's these flat valleys were really nice places to develop in the mining landscapes. And you can almost see there is a mine discharge in the top picture there. What's really interesting about this, haven't heard anybody talking about this, we have large avalanche pathways here, and this is called the Brooklyn Slides on Highway 550. In 2019, we had historic avalanche cycles, 100-year avalanche cycles. A lot of large woody debris came down, and I've been watching the last couple of years. The beavers are actually taking the large woody debris and building structures in this channel. And remember, this is primarily, spruce fir conifer, so it's not that they're materials of choice, but it's there. So we're starting to monitor the widening of the channel in these areas, and I don't need to talk about all the things we've been talking about for 3 days, but there's multi-layers. It's not just mines. And one of the things that I'm curious about here, I think I put, was, should we consider enhancement with PALs here to give the beavers a better chance of having these dams last? So we're talking 5x, 10x hydrograph changes, right, during spring runoff. So these are very dramatic, steep gradient streams, so they've got to deal with that. And then these are, flat glaciated valleys. Of course, I just heard in a recent talk, if you're going to be doing this expansion, you've got to think about infrastructure impairments. And so this is just upstream, hired by CDOT to put an exclusion fence in around this culvert. This pond sits in the middle of the highway, so there's 60-mile-an-hour traffic on 3 sides. The beaver really likes the pond because it's a spring wetland that feeds it, and the spring stays warm, so the water doesn't freeze, so he's super psyched all winter. But he's living in the middle of that. And so this is just upstream of the Chattanooga site, like within a quarter mile, same colony. This is an interesting one, the Bandora mine on South Mineral Creek. This complex has been here as long as any miner in town can remember. So we're talking, 80 to 100 years. This is an abandoned mine site. And in this water, you can see the blue color. That's actually precipitating aluminum. And the aluminum is naturally sourced from the headwaters here. And so what's really interesting at this site is that the water coming from the mine is actually a higher pH than the water in the stream. It raises the pH level enough to cause aluminum to drop out of solution. So it's actually stopping the aluminum from going further downstream in that place. Of course, the mine's not perfect. It has other metals like iron and zinc, but the aluminum disappears from upstream to downstream within this habitat. So it's very complex. It's not a straightforward thing, but it's starting to think about, fate and transport and the cycling that's occurring in these areas. So pretty extensive complexes, and it doesn't seem to be bothering them. Again, a call to a biologist. I'd love to have someone come do tissue studies because I do not know if there are accumulative issues with metals in these beavers. The basic assumption is that if they're living there multi-generationally and continuing to expand habitat, I haven't seen any 3 eyes or 5 hands. So, but not to say that we shouldn't be monitoring these limitations. So this one is Cunningham Creek. So this is the one that Ecometrics just recently worked on. As Ellen talks about strings and pearls, this would be a pearl within the string. I like to point out that in these headwater areas, it was very convenient to build roads along waterways, right? It's how you get up to the mountains. So we're dealing with these infrastructures, shrinking environments, and so where do you work with the pockets around them? In this drainage, there's several large mines that release heavy metals. There's active beaver habitat, and there's also changes in chemistry and pH within these structures. And so what I want to point out, though, is that this is an example of the BLM coming in, getting the permitting necessary to do restoration work. Ecometrics has come in this summer and started a number of beaver dam analogs and PALs within this reach where there's naturally existing beaver habitat and some, appropriate beaver habitat for expansion. So part of this is actually related to, I'm going to look at the water quality in this drainage and study whether or not there's impacts as these, hopefully, areas start to colonize, and looking at metals and sediment transport and nutrient cycling within this watershed, and are we actually slowing down runoff in these and providing better base flows into areas that have metals contamination? Acute and chronic toxicity levels are related to base flows. I won't go into that, but happy to chat more. So I just wanted to give some credit to Jessica and Mark and their team. So this is some of the new work, and I have secured funding to go back and continue to monitor these sites because they're nearby. So see how they're doing and see if the beavers that are living about a half-mile away will come in the next year or so. This is a really interesting site. The North Star mine is right in Silverton, and this site before cleanup was just a big mine dump right running into the creek. So we've got contaminated soils and waste rock and tailings adjacent to the creek. We have a mine. So what did the beavers do? They walked up the mine discharge channel. They went to the portal of the mine. They built a dam, and they started living in the mine. And great place to live, I guess. But the EPA said we can't have this because it's causing saturation of the waste rock pile. We've got water running over it now. It's actually picking up contaminants that are there. So the BLM actually came in. We were able to trap them, move them to another spot, and then come in and do the restoration work. And what the restoration work focused on was removing the tailings. Moving the tailings away from the creek, and as a result, they ended up opening up this large, several acre area, and they're like, well, what do we do? And they're like, well, we need an answer like next week because we're done with the earthwork. What do we do with the water? And I was like, let's think about this. And they're like, we don't want one big pond. I said, well, how about we do a series of terraced ponds? So we're taking the adit discharge that's fenced out so the beavers can't get to the adit, and then I'm splitting it between the ponds and this other wetland area. This wetland area is great. All the spruce are dying off, and the deciduous vegetation starting to come back with the wetted soils. But I said, hey, let's just throw an idea out there. What if we, I know I'm going to run out of time, so I'm going to kind of jump over the metals because there's too much to talk about. The ponds are removing the metals by natural filtration. But I also had the USGS come in, Dr. Thomas Chapin here in Denver. We set up mini sippers and did continuous monitoring through a whole year to look at the hydrograph and how these metals concentrations change with the hydrograph, et cetera, et cetera. But this is the cool part. What I decided to do with this landscape is I said, you know what? The Silverton school kids, let's make this their spot. So this summer we came in and we're doing willow plantings, and my thought is maybe this could be, I don't know if it's a beaver bunker, but it might be a stepping stone, of a habitat connectivity. And my thought was, what if we can just get vegetation to grow here because it's right next to the creek? The beavers can come use it. So I've given the students the kind of leadership to come in and plant and watch it, and then we just installed game cameras, and the students are counting the wildlife species that are using this kind of modified wetland habitat as they learn about mining and impacts and restoration kind of all in one. And I just recently developed a curriculum for both the elementary and middle schools in Silverton. Our K-12's 85 students, so there's only 600 people in the town. So getting them out, but it's amazing to see the 4th and 5th graders just itching to come back and learn more about it. So how am I doing on time? Killing it. So another creek that I want to talk about is Cement Creek. It's interesting, the name Cement Creek, we don't really know where it came from, but when the miners showed up, they said, this creek doesn't have anything growing in it. It's bright red. There's natural iron. If anybody's ever heard of Red Mountain Pass in southwest Colorado, Red Mountain is red because of the iron and the pyrite that's existing there. There's natural weathering, and so this creek has a lot of heavy iron precipitates in the creek anyway. There's not a lot of bugs, there's no fish, but the beavers have been showing up in here, and I'm really curious, can they handle this? Do they like this? What's going on? So you can see this is natural. This is the creek that turned orange when the Gold King mine spill came out, but that came out at 3 million gallons in like 4 hours. And so that's what made it all the way to Lake Powell, supposedly. And, it's clearly a less than visually desirable landscape. And so I just said, okay, first of all, what's going on in this water? Is it really high contaminants? We know the pH of the stream's like 5, and it's iron dominated. But fortunately, some of the other metals, again, this is log scale, so I'll give you some perspective to toxicity levels at the end so that there's some context. But some of the other metals are not as bad. And so the beavers have used this mine drainage spot, which is a perennial source of water, and then they're making habitat, and then they've been starting to go and do dam-wide channels to help flood this kind of area that they've been working on. And so we've got the mine source, we've got the active pond and lodge utilizing that perennial source, and then they're working on these dams and starting to flood this greater area. Same thing in here, you see the conifer species have started to die off. And that's one of my concerns is if you're gonna come in and do restoration work, is the food available? And a lot of these waterways, there's been so much disconnection from the floodplain that there's this encroachment of the coniferous forest, right? And so, perfect. So that's not as desirable for them, but we're seeing this turnover in small pockets. So it's just something to think about, to the naked eye, not knowing. I had some feedback on my abstract that said, you're poisoning the beavers. When I put it in for the conference, why are you putting beavers in harm's way in front of the metals? So, well, let me explain it a little bit. We're not putting them anywhere. They're showing up here. And this is a good example, too. So the problem we're having with some conflict issues is they like the aspen stands. The aspen stands, this is 400 feet of vertical relief, and they're going up to the top of the road and coming and carrying those full aspen trees from across the road and down because they don't have much forage available in the riparian area because of this encroachment from the conifers. So just, we're talking about digging canals and channels. These are hiking trails. They're 4x4. So just kind of, thinking about, what is the spatial scale on the landscape? What are the things that we need to consider? It's not just, is the gradient of the stream enough? There's a lot of other pieces with the chemistry and the available food and the infrastructure around it. I'm going to go to one more. This is the last one. This is in the Animas River Valley. And this is speaking about potential. So this is a Superfund listed site. This is the Pride of the West Mill. That doesn't look great. The river's over here. This entire valley, the river, as folks have said, bulldozer, straight line, 6 miles. And that was late, turn of the century mining because they wanted to have places to put mill tailings and do other things. But when you take a step back and look at the landscape, you're like, wow, there's beaver habitat here, there, everywhere, above, below, adjacent to it. So the arrows are these healthy pockets of active, habitat. And then you see this, massive mine tailings. And so this will get cleaned up. We don't know. We're going to do feasibility studies, but I'd sure like to be able to quantify low-tech restoration cost as they do a feasibility analysis to some of this area and see if that could be brought back in for a fraction of the cost that they spend on some of the other active, well-engineered, over-engineered kind of repository and movement structures. It's a little bit foreign for the EPA. They're not here, so it's fine. To think outside the playbook, right? I mean, the playbook is like, hey, we're going to build a treatment plant. We're going to dig this all up and bury it in a capsule. That's it. There's not a lot of process-based thought, and their job is to remove contaminants, but not necessarily see full circle restoration of the ecosystem that's being impacted. 2 minutes, perfect. Someone mentioned railroads. Have you ever seen a beaver dig under a railroad? Right, that came up a couple days ago. So this is the historic railroad grade for the mining era, and it's pretty clear that this railroad grade, but I'm running into some troubles with SHPO and historical preservation. We're not allowed to move historic railroad beds. So they have become a barrier to the natural movement of the water across that floodplain. So trying to figure out, and then this was a spur, and this whole area was contaminated. We actually removed the tailings and capped them here. We weren't allowed to move the white tailings because this is a spur with a few pieces of wood and some rail left going to the old Kitty Mac mill. So I'm not trying to pick sides. I'm just saying that's another layer of complication when you have historical preservation in these landscapes. Of course, I should throw in a little geomorphology here, right? We've got this alluvial kind of debris flow, and that tends to be areas where debris flows come into these big U-shaped glacial valleys, and that decreases that gradient, and the beavers really like to be upstream of these areas because that cuts that gradient down in the valley. Something to think about, in terms of locations. So just some big overview here. Pretty clear what happened to the river channel, right? And then you've got these really healthy pockets of wetlands all up and down, and then this is a future cleanup. It's in process now, and so just like in thinking about that from a connectivity perspective. So I'm about to end, last minute here. I got 2 slides left. I wanted to, again, it's very complicated to look at contaminant toxicity levels because we're talking aquatic, we're talking terrestrial. You hear both. EPA is saying the beavers are terrestrial, but they live in an aquatic environment. And so what I've done here is this is just quick snapshot metals concentrations at a handful of the different sites we've looked at. And the red lines are an aproxic aquatic life standard. Again, complicated, hardness, pH dependent, changes every month. But just to give you a ballpark that yes, some of these areas would be considered above the thresholds for the fish and the benthics, and then others are not. So we need to build that quantitative database to be able to come to the table when it's time to talk restoration and cleanup levels of how far off are we, and what are we thinking about, and what are we trying to protect? Because the EPA really, it's coming down to zinc and fish. That's what this 48 sites, and the compliance point's 10 miles downriver. So all of the riverways between these point sources are actually within the Superfund, which therefore they can be cleaned up to reach the downstream goal. And I'll leave you with the fact that CERCLA supersedes NEPA, so there's way less permitting. The one, lead's a tough one. Lead's, this is a human recreation standard, just to show you, and those standards are much lower than the aquatic ones, but just to show you, we're not talking lead so hot that we're having, human health problems. So calls for collaboration, build the data set, bring in more interns, more grad students, more undergrads, more 5th graders looking at game cameras, understand chronic exposure. I'd like to get someone to help me with bioaccumulation and potential tissue studies, and terrestrial impacts to beaver health, soil and sediment. And the big question here is probably sediment deposition in the ponds is probably going to be your avenue. It's not going to be inhalation, but they're in the sediments. And coordinating with partners, I think I've been able to show with funding sources, using a pretty broad set of funding sources in the same watershed, and you've got to work with all the agencies. And then continued outreach, succinct articulation of beaver benefits to diverse user groups and resource values, right? That's a greater objective of this conference. And I like to remind the audience, I really appreciate you coming, but this talk's only as good as many people that you spread the word to that couldn't be here today. So when you go back, think about sharing it with the school kids or your neighbors that don't get to sit in this room. So I'll leave you with, this is our ice hockey facility in Silverton. It's also the Kendall Mountain Beaver Pond that I started with. So with that, thank you.
Thank you, everybody. It is now lunchtime, but Dr. Cowie is going to hang out for a second. If you have questions, you can also submit them through the app.